Okay, here's a pretty kind of standard Poisson distribution question. It starts out by setting up two variables x and y, and they're both Poisson distributed with different means there and there. And we have a particular probability for x, use the formula from page 11, and we've got a range of probabilities for y, where you're going to need to use the tables, probably a bit of subtraction going on, because the tables tabulate y being less than or equal to a value. In part B, we're doing t is the total of x and y, so we're adding up two Poisson variables, and as long as those things are independent, the result will be another Poisson random variable, and you need to sort out its mean, but that's pretty easily obtained from the means of x and y. And then we've got the probability of a range of values of t, so using that distribution and the tables, work out the range, the probability of being in that range is a simple subtraction of two tabulated probabilities. The sting in this question really is in B part 3, and even that's only 2 marks. But this is a very important type of situation to look at, where we've got double layeredness going on. We're looking at 3 consecutive days. Now that could just be adding together 3 Poisson random variables. We need to look more closely at the question to see if that's what's happening. And it turns out that we're not simply interested in the total number of calls and emails over 3 days. We've got to look beyond that. We're looking at something happening on each of 3 days. What is it that has to happen on each day? At least 7, but at most 10 calls and emails, which is this event here. In B2, we worked out the probability of that happening on 1 day, but now we've got 3 days, one after the other, and we're looking at the probability of that happening at 3 times out of 3 days. This is the kind of situation where you often get a binomial distribution on top of a Poisson. You don't need to use a binomial distribution because it's got to happen 3 times out of 3. So it's got to happen on the first day, and on the second day, and on the third day, and that's your clue to what to do with that probability you found in B2, which is of this event here. Hope that helps with that question.